Now moving to third part. So in this part we are going to understand important formulas, that is from starting from Ohm's law to new concept, that is conductance and conductivity. So first we have to study Ohm's law. So Ohm's law we have studied in 10th class. It is basically defined as that the current is directly proportional to voltage. If I explain in proper definition, then it is defined as the current flowing across the conductor is directly proportional to the voltage applied across the conductor. So by solving further, we can write it as this. So by putting a proportionality constant, it becomes V equal to Ri, or we can also write it as V equal to IR. So this is Ohm's law, in which we define it as voltage across current is directly proportional to voltage applied across the end of conductor. This is basic definition, or this is basic of Ohm's law. So we conclude Ohm's law with this formula V equal to IR. Now moving to next concept, next formula, that is resistance. So then how will it define resistance? Resistance is defined as the obstruction to the flow of current. How we define resistance? Resistance is the measure of the obstruction to the flow of current. It is measure of obstruction to the flow of current. So basically it is the property of a material or a conductor which basically resists the flow of current, basically obstruct the flow of current. Now in this resistance concept, we study that resistance is depends directly with the length, and it also depends on inversely with the area. This thing we have studied in 10th class, so we are not going to deal it with depth. Now merging both these formula, we can write it as like this. So by solving further, we get a proportionality constant that is known as rho. This is, we pronounce it as rho, and this is known as resistivity. So to get it unit, we know that its unit for Ohm's law, we know that unit of resistance is ohm. By shortcut, we like it as ohm. Now moving to next concept, that is resistivity. Formula is resistivity. So resistivity is defined as the resistance of a conductor. It is defined as the resistance of a conductor of 1 centimeter length and having area of 1 centimeter square. So this is related to our formula. If I have length of 1 centimeter, 1 unit, and area of 1 unit, then it will become to rho. So resistance become equal to rho. So this I have written also in the definition, that resistance is equal to rho when we have a conductor of 1 centimeter length and we have area of 1 centimeter square. Now to derive its unit, we know that resistance equal to rho L upon A. Now cross multiplying, we will get R into area upon the length. Resistance is in terms of ohm, area is basically unit square. If I am using meter square, then length will be meter. by cutting 1 centimeter, we will get ohm, centimeter, or sometimes we write it as ohm meter. So this is the unit, ohm centimeter or ohm meter. And basically it changes. If I take centimeter, then it become ohm centimeter. If I have unit in meter, then it become ohm meter. Now moving to next important concept that is new to you, which is conductance. This is, I think this is fourth one. So next is conductance. Fourth one is conductance. So by formula we write conductance. First of all, we have to understand this is represented by symbol G, capital G. So capital G is equal to reciprocal of resistance. Capital G, which is conductance, it is equal to the reciprocal of resistance. Now to define it, we define it as it is a measure of ease with which current flows through conductor. That's why we are writing conductance as a reverse of resistance. Now deriving its unit, on R, and we know that resistance is generally in ohm, so we can write it as per ohm, and the new unit which we generally use is Simon. And it is represented by symbol S. Now what we have concluded? We have concluded that conductance is equal to 1 upon R and its unit is per ohm, or we can also write it as Simon. So I can write 1 per ohm is equal to 1 Simon. Now moving to fifth formula, that is conductivity. This is also new. So conductivity is written as K kappa, we call it as kappa, K PPA. So kappa is basically the reverse of resistivity. So by putting formula or resistance, which is equal to R equal to rho L upon A, I can write kappa as 1 upon R into area divided by L. So it will go up on to get multiplied by 1. So we'll get formula L R into A. And we can also write it as L upon A. To get it unit, as we have length R into A, length is generally meter square centimeter, resistance is ohm, length is basically meter, and area is meter square. Then we will get 1 meter square is cut by 1 meter. Then we will get per ohm per meter. Sometimes we write it as per ohm per meter. So you have to also understand one concept, that is per ohm. This is per ohm. We also write it as what we can write it? We can also write it as per mho. Resistance is in ohm, so we can also change it as mho. We read it in reverse, then we will get mho, mh. Now coming back to the unit of conductivity, so we can write this unit per ohm per meter. Now if I take 1 upon R as Simon, then what will be our unit? Our unit will be Simon, length is in meter, area is meter square, then it will be Simon per meter, or it can be Simon per centimeter, depending on the area and length of the cell which we are taking here. This can also be changed as per ohm per centimeter. So this is very important, which is generally we will use conductivity in this unit, that is Simon per meter. Now moving to next formula, that is about molar conductivity. This is our sixth formula, molar conductivity. So how we define it? We define the conducting power of all the ion produced by dissolving 1 mole of electrolyte. It is the conducting power, power of 1 mole of electrolyte of all ions produced by 1 mole of electrolyte. By the name we can also conclude molar, it is molar conductivity, so it is for 1 mole of electrolyte. So how we write its formula? It is represented by lambda. Sometimes we write it as this, sometimes we can also write it as this. So for molar word we write it as molar m, small m. So molar conductivity is basically equal to conductivity per mole of concentration. So we write it as concentration. This is molarity. This is the main formula of molar conductivity. This is main formula. Now what we have to understand in this formula is its unit. Kappa, what we have derived? For kappa, we have derived that kappa is Simon per meter, and we know the concentration is mole per liter. So this liter will get multiplied to numerator and will become as liter upon mole. So now you have to understand that meter, we have meter with power -1, but liter is also a volume which can be written in terms of meter cube, centimeter cube. So I am writing here, we know that 1000 ml. First of all, you have to learn that 1 ml is equal to 1 centimeter cube. So 1000 ml will be equal to 1000 centimeter cube. So I can write it as 1000 ml upon mole. Then I can also write it as ml in terms of centimeter cube. We have just derived 1000 ml equal to 1 ml equal to 1 centimeter cube. Then it will become 1000 Simon. If one more thing we have to correct here, if kappa is in terms of centimeter per centimeter, then it will become centimeter with power 2 and per mole. So to get units according to our question, we have also changed this formula, like kappa into 1000 upon my concentration, it is equal to molar conductivity. So when we will be using this formula, if kappa is in terms of Simon per centimeter, then how we will get the unit? We will get the unit of molar conductivity as Simon centimeter square per mole. So you have to learn this. Now talking about this, if I have molar conductivity in terms of mole per liter, and this unit is Simon per meter, then we have to change it into centimeter, or we have to change the denominator concentration in terms of ml or centimeter cube. So this portion I will be discussing in next part. So thank you so much.